Hello students, welcome in the next session of chapter 1. The main topic is terminating and recurring decimals. First we will have a short review of real numbers. Real numbers, a number whose square is non-negative is called a real number. Take an example. Suppose x is equal to 2, squaring on both sides, x square is equal to 4. So what is the definition? Square, a number whose square. We are taking a number x is equal to 2 and squaring, we will get a non-negative number. A number whose square is non-negative is called a real number. Now take a negative number, squaring it, so you will get positive number. So non-negative number means the number which is not negative and which is positive. So these are called the real numbers. All rational numbers and irrational numbers are called real numbers. What are rational numbers? Rational numbers, the numbers which can be expressed in the form of p upon q, small q. The number in the form of p upon q, where q is not equal to 0, p and q are integers. So these are called rational numbers. The main thing in rational numbers that p and q are co-prime. It means no common factor other than 1. And irrational numbers we will discuss in next video. We will take this topic, irrational number, in coming video. Now another topic is equivalent rational numbers. Equivalent rational numbers are numbers in short form. What are the equivalent rational numbers? Suppose we are taking 1 upon 2. So equivalent rational numbers, 1 upon 2 is p, and this is 1 is p and 2 is q in the form of p upon q, and no common factor other than 1 in both the integers. Now make it equivalent rational numbers. So many equivalent rational numbers we can make. Multiplying numerator and denominator with same number, you will get equivalent rational numbers. So when multiplied by 2, you will get 2 upon 4. Next, multiplied by 3, both numerator and denominator, you will get 3 upon 6. Next, multiplied by 4, 4 upon 8. So you will get so many rational numbers and you cannot count it. So many rational numbers you will form by multiplying numerator and denominator with the same number. Suppose we are taking a rational number 6 upon 8. So what is the simplest form of this rational number? You can 2 3 is 6, 2 4 is 8. It will not further divide and no common factor between 3 and 4. So 3 and 4 have no common factor other than 1. So this is the simplest form of any rational number, and you can find out simplest form of other rational numbers. Take an example. Suppose 22 upon 88. So you will get the simplest form of this rational number, 2 upon 11 2s are 22, 11 8s are 88. This will not in simplest form because it have a common factor. It has a common factor as 2. 2 1s are 2, 2 4s are 8. This becomes 1 upon 4. So it means 1 upon 4 is the simplest form of rational number 22 upon 88. Here no common factor other than 1. both are co-prime numbers. This is the way to find out simplest form of any rational number. Or you can find out HCF, both the numbers, numerator and denominator, and divide by HCF. Then you will find out the simplest form of rational number. And uh, in this method, the steps involved, and when you divide by HCF, only one step will be there. So easily find out the simplest form of rational number. All rational numbers and irrational numbers can be represented on real line. So when we find out the rational number, we can represent on real line as well as irrational numbers also. Now next topic, which is the main topic, rational numbers in decimal form. Every rational number when expressed in decimal form is expressible either in terminating or in non-terminating repeating decimal form. What is the mean of this statement? So we will clear it with the examples. Now we will discuss main topic. Every rational number when expressed in decimal form, it can be expressed in terminating or in non-terminating repeating decimal. So first we are taking terminating decimal. What is the meaning of terminating decimal? If the decimal expression of a rational number p upon q comes to an end, then such decimal expression is called a terminating decimal. We will understood it by an example. So we are taking an example. Suppose example number 1, 1 upon 8 is a rational number. 1 upon 8. It is in the form of p upon q. Now when we will express 1 upon 8 in decimal expression, so divide 1 by 8, which will not divide, put a 0, then point, take a 0, 8 ones are 8, 2, put 0, 8 twos are 16, 17, 18, 19, 20, 4 remainder, point is here, so again 0, 8 fives are 40. So you are watching that it comes to an end. This becomes 0.125. The rational number p upon q, which is 1 upon 8, will be expressed in decimal expression which comes to an end. This is an example 1. Now take another example. This is example 1. Another example 2. Suppose 6 upon 25. Now express it in decimal expression. Divide 6 by 20. Divide 6 by 25. It will not divide. Put 0, then point, then 0. 25 twos are 50. Now remainder is 10. Point is here, so we can put 0 here. 25 fours are 100. So this decimal expression comes to an end. 6 upon 25 can be expressed in decimal expression 0.24. Take another example for your convenience. Example 3rd. 2 upon 5. Divide it. 2 by 5. 0.0. 5 fours are 20. This also comes to an end. This becomes 0.4. All three examples showing that a rational number which is in the form of p upon q comes to an end when it is expressed in decimal expression. So the definition is proved with the example. Second type decimal expressions. are repeating or recurring decimals. If the decimal expression of a rational number p upon q repeats periodically, then such decimal expression is called a repeating or a recurring decimal. Periodically means a set of digits or a digits repeats again and again. So this is called the periodically. So we will understood by taking example. Now divide 3 by 7. 7 0 point to 0. 7 4 the 28, 29 30, 2 remainder point is there, so put a 0. 7 2 the 14. Now remainder is 10 minus 4. 6 point is there, so put a 0. 7 8 the 56. Now 4 is remainder, put a 0. 7 5 the 35. 5 remainder point is there, put 0. 7 7 the 49. 1 remainder point is there, put a 0. 7 1 the 7. 8 9 10, 3 remainder, put a 0. 7 4 the 28. Now 2 remainder point is there, so put a 0. 7 2 the 14. Now divide further, and what are you watching here? That this becomes 0.428571. 0.428571. Here these digits is a set of digits, and from further the digits are repeating. Further the digits will come 4 2 8 5 7 1, and this will be continue. So if this will be repeated, so you will put bar on the set of digits. Such type of decimal expression is called non-terminative repeating decimals. This is another example of repeating decimal or recurring decimal, 11 upon 9. When we divide 11 by 9, we will get 1.2222. It means the digit 2 is repeating, so we put bar on 2. So this is the form we write to terminating and repeating decimal. Now next is to test whether a given rational number is terminating or non-terminating repeating decimal. What we have to test? Rational number is terminating, or other type non-terminating repeating decimal. So which type the rational number will be? We will find out a method which we are using here. A rational number p upon q is terminating decimal only when prime factors of q are 2 and 5 only. So what we will do here? We will take an example. 3 examples are there. First 3 upon 10, second is 9 upon 20, this is second, and this is third, 17 upon 25. what the definition said, prime factors of q. So here in first part q is 10, we will do prime factor of 10, 2 and 5. Only two factors, 5 to the 10, 2 and 5. And what is the prime factor of 20? Break it in prime factors. 2 into 2, 2 to the 4, 4 5 is 20. And do the prime factor of 25, 5 into 5. So what the definition, according to definition, here the denominator q, and q has the prime factor 2 and 5, 2 and 5, 5 only here. The third part 5 is the prime factor. So the meaning of this will be the denominator of each has no prime factor. The denominator of each has no prime factor other than 2 and 5. Here you are watching that only prime factors are 2 and 5, not other. Suppose 3, 7, 11. Here no other prime factors except 2 and 5. Such type of rational numbers are called the terminating decimal rational numbers. Okay. Now what we have concluded, two types of rational numbers. First is terminating rational numbers. Second is repeating decimal numbers. Repeating decimal expression. So this is the type of terminating decimal numbers, and this is not the non-terminating, or we can say non-repeating. This is only terminating decimal numbers. Okay, we will more expand it in the exercise, and we will do exercise in my next videos, so be ready for that. And till then you can subscribe, share and like my video. Thank you.